All right. Cool. All right, welcome back to this new meeting today. This is the 12th meeting of the GDC. So in the previous meeting, it was all about like game designing and all that stuff, how to find a new technique, a new approach in designing your games, planning it out, and brainstorming. Because obviously, building a great foundation from the beginning is the best way to make a great path that will eventually lead you into making a better game. If you do not really start off with a really good path or from a good foundational structure, you might kind of wear off in your process. You could like jump out, or you could give up eventually. Or sometimes if you don't really have a clear and focused kind of like you know a goal, some sort of goal, right? And that's all happening through brainstorming. So we learned many different techniques. We learned about onion design. If you would like to learn that, go back to the previous video and you could check that out. I've also put the timestamp on that as well. So yeah, so today what we're gonna do is there are actually quite a lot of stuff that we'll do today. Uh, since we have only like five classes, like and maybe if you're not in GDC, then 5 videos. You have like 5 videos or 5 classes to work on this project, the project boost. So we kind of need to be very clear. Not maybe clear is not a better word, but we need to be very fast and very fast, okay? Because we're kind of short on time. It's very constrained there. But today we're going to talk about units. So we're going to figure out how Unity kind of measures stuff. Do they measure in meters or in centimeters or anything? We'll figure that out today. I don't want to spoil the answer because it's kind of cool, the answer to that. We'll also start making our environment. So today I actually want to teach you like hands-on on how to actually level design. Or in other words, what's my approach in level designing. And maybe you could take inspiration from that. And then perhaps in your final project, which you will have to submit next year to get your certificate, then you could maybe incorporate that into your own game and make it better. We always want to get answers from different perspectives, and obviously we want to be eclectic learners, right? Additionally, I'll also teach you how to make characters in Unity. Like I've been telling you for assignments and make this and make that, but now I kind of want to get closer to you guys and kind of teach you these small techniques that could perhaps help you in your next project. Because the thing is, practice doesn't necessarily make perfect; it makes improvement. And I want to make sure that the more we practice in Unity, we eventually do better on this new project than our previous project, right? You want to kind of learn from the mistakes you probably did in the previous project. I've heard from a lot of you guys that you were encountering some bugs in your game, so we could find different ways to, deal with those bugs and find solutions to it. So we'll, in these kind of videos now, in this video specifically, we could also go over that. Additionally, we'll also go over like GetKey, GetKeyDown, GetKeyUp. I have already covered this, but I haven't made a video on it, so I kind of want to maybe like show this up on the video so that anytime you want to access something, there's a clip for that, and you could access that on our channel. All right, so and just to give you an insight, we're not going to use get access in this project. I kind of want you to be very flexible in using different type of features, and I kind of want you to be open right now. Don't be that type of person that, okay, I'm this side, I'm like get access type of person, not the input.getKey. Right, I want you guys to like at least use both of them because they could be used in various different situations. One could be better than the other, and since this game is only going to be played on computers, not necessarily on like a phone or like maybe on a console, maybe you could work on these things if you want for phones and consoles at your own time. But the project that we'll be making for this unit is basically just for PC and Mac, so we could just use things like A and D keys and the spacebar, and honestly, just using input.getKey is going to help us there. We're also going to learn about how to use AddRelativeForce. Okay, so in this game, we have a rocket, right? And in the maze game, we just had this sort of cube that we were moving around the environment. So for the cube, though, we can just use the WASD keys or the up arrow, down arrow, left arrow, right arrow keys. And to simplify that, we use the get axis, right? But in this game, we're not going to be like, hey, if you press W, it's going to go up. And if you press S, we're going to go down. No, what happens with the rocket, right, is that we have a booster. It's boosting it to go up. But if we don't boost it more and more, if we just eventually stop boosting, it will come down, right? So what we're going to do, like our own mechanic, our own technique into moving the thing up and down is using the spacebar. The spacebar should act as a booster. So it kind of gives the player a connection to the game, that they are the player of the rocket. And they're playing as a pilot who is who's riding the rocket and piloting it. So you should kind of feel that way, like you're riding a pilot, basically. So we're going to use the space bar to, make like a booster, and if you stop pressing the space bar, it will come back down. So it kind of gives a challenging process to it. And we'll use only A and D keys to move left and right. Maybe a better word is rotating. And we will also talk about that today by making a script, especially the movement.cs script, and finish that up, making the rotation. So eventually, by the end of this video, we should have like an environment ready, and also like a player ready, that rocket that's ready to move and be thrusted around. And in those next lectures, in the future lectures, we can learn about constraining those type of rigid bodies and stuff, how to make it more realistic in terms of for the rocket using the thing called drag that's found in rigid body. But we will again go over that in this next few lectures. So for today, we'll just focus on making the land, like the environment, learning level design, also learning character design, and also like finally making some movement scripts for the character. All right, whenever I say character, my apologies. I try to say I'm trying to say the rocket. All right, so let me just give me a moment. I'm trying to share my screen. All right, so I hope you guys can see it. All right, so I'm gonna talk a bit about what Unity units are. All right, so if I actually go to Unity, right? Now, I made a scene already. If you guys didn't make a game project yet, make a game project already. If you're not familiar with that, again, go back to the videos on YouTube. You could check it out. So what I'm going to do is I'm just going to create a 3D object just to give an example. A cube. Cube is probably a good example here. If I press, let's say, you don't know where you are. Let's say you're this far away and you want to access that really quickly. You can actually press F on your keyboard, and that will just instantly navigate you through that object that you selected. Okay, and that's just a more effective way. All right. And what we'll do now is I'm just going to try to tell you what I'm trying to talk about the units. All right. Now we see that thing on the right, right? We have like a component called transform. Well, if I move the x-axis, right? Now x-axis, we have 3 coordinates, x, y, and z. Z coordinate, because this is a Cartesian coordinate system, and it's three coordinates, which makes up a 3D game, right? So let's say for the position, I move it to the right. Now, it's moving to the right. Maybe like a better way is to probably reset it. So if I right click and press reset and I press F again, let's say I want to move to the right by, 5 point, let's just say, I guess for now, 6. Okay, I maybe want to go back. Now, it went to the right by 6, but 6 what? 6 centimeters, 6 meters, 6 kilometers? Probably not kilometers because it's pretty close to each other. But we want to know, is it 6? What is it? What's the measurement? Or maybe perhaps for scale, is it going to the left? Is it scaling by 11.6 centimeters, meters, or something? You kind of get my idea, right? So what's the real measurement for this unit? Hopefully, this will answer your question. Does Unity have a unit? No, it has no particular measurement at all. So it has it's just a placeholder number. So if you think of it, it has nothing. It's not measured in meters, kilometers, feet, inches. It's literally measured in nothing. So if I'm gonna say it went to the right by 1, well, it just went to the right by 1. It didn't go by 1 centimeter, meter. It just went by 1. Okay, so we just say the number without any measurement unit in Unity. However, now this is where things get a bit tricky. We could actually make that number become a particular unit in our mind in Unity. So in a way, what I'm trying to explain is I could go to this object. I might want to reset this again here. Let's say this object, right? We have this thing here. Usually what people do is they add another object and they add a picture on the bottom, all right? On this bottom surface, like let's just say something like here. And what they do is people would trace around using those game objects and they try to mimic the real life measurement. So let's say you measured your table and you measured your table in meters, maybe in centimeters or meters, preferably meters because that's an SI unit in the mathematical realm and also the scientific realm. So obviously meters are preferred to do, but you could always measure in centimeters and divide by 100, I believe, to get meters if I'm not wrong. So when I try to say that, you could try to pretend that these values are incrementing, or let's not say incrementing, it's moving or increasing, decreasing by a particular type of unit. But for now, to avoid any confusion or complications, we should just say that there are no units on Unity. There is literally no built-in measurement or anything. And even if you're going to mimic the measurement, it still has no real measurement to it. So if I'm going to the right by this amount, well, it's just going to go right by this amount. There's no unit to that. So just keep that in your head, okay? So this is the big idea about Unity's measurement system. All right, so if we kind of like pretend to follow a particular unit in our head in Unity, it'll actually help us compare the measurement in terms of the real world. So like, let's say you made an object, right? And you try to create your own scaling, like people do that on maps, like this much is 10 kilometers or something. So you could do that something on Unity as well. And that will just help you compare that is your size, what's your size relative to the entire planet itself. Well, let's not say the entire planet, but to the environment in the actual world, so that you could make sure that, okay, if I made a table, it's not like the size of a planet, but rather the size of an actual table, or something smaller than a bed, for example. All right, so this is what I'm trying to talk about when I say, does Unity have a measurement? Again, you can access this on the keynote if you'd like. It's always over there. All right, the next question, it's not really a question, it's just to let you know that how we will be using each of the axes for this game so that you guys don't get lost. We want to keep in this orientation. So when I say that, your Z should be behind, right? Should be forward. So that means that it should be responsible for forward and backward. The X-axis is responsible for left and right. And the Y-axis is responsible for up and down. So clearly X and Y are responsible for, as the things we know, right? Because even if we played a game or we did mathematics, X is, the horizontal plane, Y is the vertical plane. But we also want to make sure that Z-axis is at the back, not the front. Otherwise, you'll probably have to inverse everything. And to avoid that tension and nonsense, just don't do that. Just put a Z at the back and you're all good. Okay? So this is what I want to tell you guys so that, you don't make any confusion, right? So because sometimes what happens is some of you guys might make the X front and back, right? So you can see that over here. X becomes front and back. If it was this scenario, then Z would be left and right, but still Y would be up and down. Or sometimes, some of you guys, I don't know, rarely, occasionally, you could make the Y front and back. So I'm trying to tell you that you could orientate your game in many different ways. So just to let you know, we're going to orientate it in a particular way, and you could always check this video again to figure out whether you've done it the same or not. But this is very important, otherwise you might have to do a lot of changes in your measurement, and you definitely don't want to do that. All right, so let's actually begin making the environment. All right, let's make that game level designing. All right, we need to have that in our head. We need to kind of grasp that sort of knowledge to be a good game developer. We need to know how to level design. If you do not know how to level design, you will probably have trouble in the future making your own games by yourself, which is probably going to be the case. So to avoid that, let's actually start learning this. So first, what we would usually do is kind of picture it. Okay, we might want to draw it in some particular paper or something. Just draw it out, all right? And just picture all the necessary things you need. So for our game, we need these following things. We need a ground, right? We need some sort of thing where, the rocket can stay constrained within. So like there's a land there. If there is no land, then how is there a game, right? Otherwise, you're going to confuse the player or something like that, right? You don't want that. So for us, to make things a bit more fun, since for me, I'm trying to make a game like on a planet, a Mars-like planet, I obviously need a ground because Mars has some sort of ground. And then I want to make a landing pad where it should be landing so it could proceed to another level, like the goal script, right? We made the goal pad in our previous game project. We'll be doing the same thing here, but this time we'll also have a launch pad, right? The launch pad is where the rocket will stay. It will start from there, and it will launch from there. Eventually, the point of the game is to go from the launch pad to the landing pad. And once you touch the landing pad, it should take you to the next level of the game. And this is the rocket itself, right? So we need to also make the character as well. So actually, let's go back. Oops, that's not what I meant. All right, so let's actually go back and actually start making this. All right, so how I would start first is let's actually just remove the cube. I would start making 3 empty game objects. I would first call this first empty game object the main environment. So these would be the things like the ground, the landing pad, and the launch pad. I wouldn't put the rocket in the main environment. I would keep it as its own type of group. And that is also its own category. And then we also want to make obstacles because eventually, not today, we'll eventually add some other obstacles in the game where if that character collides with those specific obstacles, then it will make the player replay that level again. All right. In my old project, when I was making this, I kind of said that if let's say you were in level 4 of the game, anytime you hit the obstacle, it will just reset you to level 1. Regardless of what level you are in, it will just reset you back to level 1. And that kind of makes people mad. Okay, I've seen people, I've experienced this, I've seen people get really mad. I play tested it with many different people. They didn't like it. So what I'll do for this game is I'll make sure that, we fix that up and just only reset on that particular level rather than going back to level 1 to avoid that confliction, right? So let's actually start off with the main environment, all right? So what I would do is I would right-click on the empty game object and create a random 3D object. All right, and what I want you guys to do before you do anything, make sure each different empty game objects, their transform thing is reset. Okay, make sure it is reset. Otherwise, it's not going to work out. You're going to make more problems than anything. So just make sure it's all reset to avoid any problems in the future. What I'm going to do is I'm going to click on this cube and I'm going to call it the ground. So this ground is responsible for making, the base, the foundation of the entire game. So I'm going to probably scale this to probably, I don't know, maybe 100 might be too much. I'm not sure. But I think that's okay. 100 is fine. And then I probably want to get some depth to this. So I want to probably add it by 30. Right? And I also kind of want to give some z-axis so it's, it's not like a line that the thing has to walk on. You should kind of give some wideness to the land itself. So I'm also going to make that around, I don't know, 30 as well. That looks good. I like it. But what the thing is, if you see it, once I've increased the height for this, right, it increased both the top and the bottom. So it's a bit like a symmetrical increase. So it's increasing both sides by 15 to make the total of 30. So that's the same idea when I'm talking about this. And the way you could recognize that is whenever you see this transparent gray stuff, the gray lines, it's kind of like saying you're where the center of where the base is really. And anything below that is just negative, honestly. So this is the 0 line if you think of it. So this horizontal line is basically the 0 line. So what can I do in order for this to go down on that 0 line? Well, we could click on the position and decrease it by 15, right? Because as I said, it increased symmetrically. So when I increase anything in the y, if I scale anything in the y-axis, it's going to scale on both sides equally to get that total of what you've asked for. So if I asked for a total of 30, it will increase both sides by 15. But I don't want the top to be on the top. I want that top to be on the 0 line. So I have to decrease it by negative 15 for it to approach that 0 line. All right, and right now it looks good, so I'm going to keep it like this. However, I do want to make some material, so I'm going to create a material. And I'm going to call this the ground. And I want to drag it, and then I could change the albedo color to something like maybe dark orange-ish color, because Mars is like that, basically. So let me just find a color for that. This looks okay. Obviously, you could, change this at your own time if you want. But this looks okay to me for now, and I'll just keep it like that. All right, so I'm actually going to keep the materials place where it is so that I can make more materials eventually. Let's see what else we need to make. We need to make the launch pad. All right, so let's actually click on the main environment again, and let's create a 3D object. This is apparently the launch pad. So this is, oops, let me just, why am I dumb? Just press F. I just literally taught you this. What am I doing? Anyways, okay, this is okay. So let's say I want to scale the Y to, let's say, 0.5 because I don't want it to have so much height. And like maybe we could make this that seems too big. So we could probably should make it like around 2 by 2. Maybe that's okay. Or maybe that's too small. That's too big. Okay, I think that's okay. So we could make it 5 by 5, like the length and width. And what I can do now is if I want this thing to come back up, we need to increase the Y by 0.25, right? Because half of 0.5 is 0.25, and it increases symmetrically to get that total. All right, so now it's perfectly on the ground. All right, so let's just I'm gonna move back out, and I'm gonna probably move that to the left side because obviously we'll start from the left side. All right, and I'm definitely gonna call this something. So let's just click on it. I'm gonna call it a launch pad. All right, and I'm gonna Control D again. All right, and I'm just gonna drag it to the right side. All right, and I'm just gonna call this the goal pad, I guess. I don't know. What did I say? The landing pad. Okay, let's just call it the landing pad to avoid confusion. All right, so once we made all these different objects, that looks cool. But how can I distinguish between these things, right? Because they're the same color. That's where materials come in. So let's actually create 2 more materials. One material for the launch pad. Usually, I just call the material's name the same thing as the object's name to avoid confusion. So I'm just going to drag that to the launch pad, and I'm just going to change the color. And I think for me, it was a light blue color, a lightish blue color. So let's just go for something like that for me. Obviously, try to get your own color. I don't want you to copy what I did. Try to be very creative. That kind of just builds up your brain knowledge as well eventually. So honestly, that's just my honest tip to that. All right, so let's just do that. And I guess that looks okay for now. I'll change it later if I'd like it. But I'm kind of concerned with the color. So I'm going to change that a bit too. I'm going to change that to a darkish blue color if that's fine for you guys. Sorry about that. And I'm just going to create another material again. And I'm going to call this the landing pad. And I'm going to drag that to the landing pad. And I'm going to change the color to probably something like green. So it kind of indicates the user that this is where the goal point is. Okay, I don't know. Oh, I shouldn't have pressed the escape key. Shouldn't have done that. All right, that looks okay for now. And obviously you could, tweak with the metallicness and everything, but this looks fine for me, so I'll just keep it as it is. All right, and we want to create the character. All right, so let's like figure out how we make a character in Unity. Well, first of all, we want to add any 3D object into the scene, because obviously it's preferred to select any object at first. Just select one, but that goes best with your overall shape. So we're trying to make a rocket. Rockets are usually cylindrical or, rectangular. For us, since it's a pixelated game and it's very simple, because it's our game project, not necessarily like our final game project that we'll be selling or sharing to the actual community, we're just probably going to use rectangle for simplicity. So for Launchpad, for example, we could use a cube. We could start off with the cube. And for an apple, we could start off with a circle. And eventually we could use maybe like a pro builder tool and, start tweaking the things, like maybe sculpt it into making it an apple. Then we want to set that 3D object into a prefab, and you want to set that prefab name to your character name. Also try to set your 3D object name in the environment the same as the prefab before you actually set it as the prefab, otherwise problems might occur. And then you want to double click on the prefab itself and then beginning editing your character from there. And that will just prevent you from any hassle in building your desired character. So it's only focused on building the character. And usually this is actually a best approach for me, at least, because it prevents from touching any other things in the environment. So like, let's say I was going to start making the character here. Well, accidentally I could start touching this, and then I could start touching this, and I could start moving things randomly. I don't want that to happen. At least I'm concerned about it. So in order to prevent that stuff from happening, I could just make a prefab and edit specifically from there. So it's only focused on the prefab itself, and you won't be touching anything other than the components that are in the prefab, which is a really, really great tool. All right. So, but obviously, if you do want to do it in your environment, you could obviously click on this. Where let's not click on main camera. I'll just give you an example. If I click on this, the hand tool, and I click on this again on the orange place, I cannot click on it because I clicked on the disable tool, which doesn't allow me to do that. So, as I said over here, doing that tool is good, but what happens is it's very time consuming because you have to manually turn it off and turn it on. So obviously we should try using the prefab technique because that's just going to be a more effective way to do it and more efficient way. Obviously you want to try many different ways. Try to be open-minded in this game development world. Do whatever you can, but surely be open-minded because there's not only one way to solve problems. Okay? So now we're going to actually create a character. Alright, so a lot of you guys make one mistake is that we just start designing the character immediately. What I want you guys to do is just start making a random object, okay? So for me, let's just start off with a cube, right? And it's already centered because I already centered this group already. So I mean, it's just a cube, right? So then what I can just do for now is I can make the Y object go up by 0.5. Eventually, I probably have to change it, but so I guess I can just keep it at 0 for now. So let's say I want to scale the y-axis by some amount. So let's say I want to scale it by 3.5 perhaps. So let's maybe, is that 2? I don't know. Yeah, it is 2. So I would have to go up by 2, right? 2-ish, I think, if I'm not wrong. Yeah, I might have to maybe decrease by 1.75, I think. Yeah, so yeah, I think 1.75 times 2 is 3.5, if I'm not wrong. Yeah, it should just take me up. So this looks like a simple game object right now. Eventually, I could decorate it in the future, which I will teach how to do. It's going to be really fun. But for now, what I can do is I can just click on this character. Actually, I may not even need this character, so I might just as well take it out of the group and just remove this. I'm just going to put that above, and I'm going to change this cube to the rocket. All right, the rocket's the main character. Now what I'll do is I'll click on prefabs. I made my own folder. Make sure you guys do this for organization. Make your own folder for prefab, and I'll drag it into there. So now I have my own prefab for rocket, and I can access it in different levels. But the cool part is if I double click on the rocket, I could actually start doing whatever I want. So inside of here, I can start adding new 3D objects, like say like a new cube. And once I start, I shouldn't probably do that. I should reset the position first. And oops. I don't know what's going on. Hold on. Okay, I think I changed the axis for this as well. So I might have to make this 0. Wait, no. 0. Okay, I'm having a lot of technical difficulties today. All right, so let's just say I made something like this, and then I decreased it, and then I decreased this side a bit, and then I moved this up front, right? Let's say I did that. Oops, I shouldn't have done that. Yeah, so let's say I did this. Now what I can do is if I go back, it's gonna apply the change on that as well. So this is something I want to talk about. Prefab is a really cool way of like editing your characters. Just you get so much focus on developing your character rather than touching anything else in the environment. All right, so it's the most effective way to do stuff in the game. Speaking of prefabs, let's actually make the prefabs for each of these other things that we made in our main environment. So let's actually add the ground to our prefab, the launch pad to our prefab, and the landing pad to our prefab. So we have each different things as well, and everything is organized as needed. And I like it. It looks really cool at the moment. All right, so let's actually save it before we do anything. All right, so let's go back to our keynote. Yeah, so make the necessary game mechanics first. So as I said, try to make your environment first, and then start making your character. Don't make your character the necessary priority in your game development. You need to make that usually the last. But yes, obviously it's necessary to plan out the character first, or at least have some picture in your head. But don't start making it in the Unity game engine as one of your priorities. Designing and planning your character and illustrating it, sketching it, that's more important than actually making it in the Unity, because then you need to have a lot of planning behind it. That's why making a foundation plan for your game is always necessary, so that you could always hope for getting a success in your game project. All right, so hopefully that kind of gives you a good insight on how game development works here, and understanding what's the priorities when you make your own games. All right, so let's actually talk about GetKey, GetKeyDown, GetKeyUp. Some of you guys already know this, but this is just like a review because you'll be using this. We'll be incorporating GetKey mostly in our game for the movement for the rocket. So we're not going to be using GetAccess, although it's a very, very great tool. But GetKey is already effective for us here, and obviously, as I said, we should be open-minded. So let's actually just get a recap of what it is. Again, you guys can go down here. If you click on any of the links, it should take you to those documentation, and it's by Unity itself. So, and obviously, as I said, Unity documentation is the best. So in case you're stuck anywhere, always use the Unity documentation to help you clear out any problem in your game. All right, so GetKeyDown will only happen once you hit the key. All right, so if you press the keyboard, the moment you hit it is the time it's gonna work. Otherwise, it's just never going to work again. If you release it, it's not going to work. However, GetKey will always happen when you keep on holding the key. So, as long as you're holding it, it's going to happen. But GetKeyDown usually just happens once, and that's kind of good sometimes because, it prevents any bugs in your game. So, like, let's say you're going to shoot something. If you're ever going to use GetKey, then it could be a bigger problem than GetKeyDown if you were going to use like a revolver. Like revolver has a cooldown or something. So you could either use invoke like Iron Numerator, which we'll talk about later in this Unity section, but it's usually used for these cooldown things. Or you could use GetKeyDown to prevent anything like that happening. GetKeyDown is also used when you're trying to move one step, rather than continuously moving in the game. Because there are some games where you might not want to walk continuously, but rather like step by step every time you press the key, right? And so that's when GetKeyDown is helpful. GetKeyUp though is always going to happen once you release the key. So it's not going to happen when you touch it or hold it. It's going to happen once you release the key. So people use it for power-ups or anything or something like that, but it's not really a used key. So the most important stuff you should know is the GetKey, and then after that, GetKeyDown. If you want to know a lot about GetKeyUp, you could learn that yourself again from the documentation, but they're not really used. So let's just stick with GetKey and GetKeyDown. All right, so let's talk about AddRelativeForce. As I said, we're not going to be making W and S keys for it to move up and down. We're going to use the spacebar as if, we're giving some thrust to the rocket for it to go up. It should make it feel a bit more realistic in a sense so that, it has something to give it, and that is AddRelativeForce. So we're gonna learn what AddRelativeForce is before we start incorporating it in the game. All right, so let's actually understand what vector and scalar is in order to understand what AddRelativeForce is. Well, vector, it has a direction, right? We learned this in physics, and if you didn't, this is a good time to learn about this. It's something new, and it's gonna be fun. So vector has both direction and magnitude. When I say magnitude, is some sort of quantity like 300 boxes or 1 pencil. But scalar, it has no direction but has magnitude. So when I say has direction, has magnitude, I'm saying that whenever I say something like 300 boxes, it's gonna indicate that, okay, you're telling me it has a value, and that's true, 300. But it doesn't tell me direction, right? So maybe putting it here isn't a really good example. So 300 boxes in this scenario would be a scalar quantity, right? Because 300 boxes is only telling you the amount it has, but not really telling you where it's going. Whereas position is a vector quantity. So an example of a vector quantity is if I click on this rocket and go to the position, that is a vector quantity. Because if I move right, it's moving to a positive amount once I reset the position of this. And it's telling me that this value has some quantity, which is 4.39, but it's also telling me that it's going positively to the right direction, because we made the right direction the positive direction and we made the left side the negative direction, right? So what I'm trying to say is that when I say 4.82, that's indicating both that it's going to the right, which says it has a direction, and 2, it has a value. Similarly, if I was gonna go to the left side, it's gonna be a negative value, and it's indicating that, okay, it's going to the left side because of its negative value. But it's also giving me a value as well, which is 4.34 in this case. So this is an example of a position. The idea of a position is telling you how far has it gone from its origin. So it's not necessary that the x value has to be 0. It could actually also be 1. So its starting position could be 1. And anything going below 1 is considered a negative value. And anything above 1 is considered a positive value. So depending on what starting point you have, it's still going to follow that idea of a vector quantity. Okay, hopefully that kind of clears out about what vector quantity is and what scalar quantity is. So scalar quantity would be something like 1 pencil. Saying that 1 pencil does tell me that a magnitude, a quantity, that this is only 1 pencil, right? But it doesn't tell me a direction. It's not telling me it went 1 pencil to the right or 1 pencil to the left. So that's the difference between vector and scalar. So hopefully this should be like a review for you, but those who are new, congratulations, you have learned something new today. And if you're still confused, be sure to ask in the comments or in the GDC server. All right, so now, actually, what is AddRelativeForce? There's actually a lot of things. There's a lot of things that you see here. Let's just go one by one. It is a method accessed by any object of a rigid body component. Now, that should kind of give you a bell. We do not have a rigid body component in our character. So we actually have to go to our prefabs and manually add it there. I always want to give you how you get this habit that you always add anything that's a prefab inside of the prefab. Any components, add it inside the prefab of that thing. All right, and this just allows you to, because if you put anything inside the prefab, so you edit within the prefab and you add the component from there, then it will get updated to all the scenes out there. So you don't have to manually add the rigid body to each scenes. So it will just it will save you a lot of time from doing this. So let's just add rigid body. As I mentioned before in other lectures, a rigid body is just the thing that helps recognize physics in the game engine, and it's really, really good. So it's good. Now we have a rigid body. So if I get out of this thing and click on the rocket, we can see that, oh, now it has rigid body. So it is actually a method accessed by the object, any object that has a rigid body component. So remember, we need to make an object in our script, right? And we call it anything, which is RB in this scenario. And we make that object reference to a specific component in the game engine. So for this scenario, we would say RB equals getComponent. Remember this thing? If you don't remember what getComponent is, again, go back to the previous lecture videos and you'll figure it out. And type rigid body and end it always with a semicolon. And obviously, it uses vector quantities. Now, I'll talk about what vector 3 is. So if you put in anything that's in a relative 4, it's going to ask you to input a vector 3 parameter. Parameter is anything you pass into a method, and it does something with it. All right, so one thing that will ask you is to input a vector 3 parameter. So what is a vector 3? To give that insight, it's just, as we said, vector has a direction and a magnitude. So this value will tell me the direction of this thing and the value of it. Right? And when we say vector 3, 3 should kind of give you, it could signal you that it's going to pass in 3 values, which is the x coordinate, the y coordinate, and the z coordinate. Because if we see in Unity, we see that there are actually 3 coordinates, right? That makes it literally a 3D game. So this is very necessary to understand because when we're going to be working in a 3D environment in Unity, we will be using vector 3. Whereas if we're going to be working on a 2D environment, we are going to be using vector 2 because it only passes in 2 values, which are x and y. We're going to also understand why vector 3 is better than any other approach, which I'll show you once we start using this inside of the script. And we can either, add the relative force, or we can add the relative force, something like this. So I think I put this in the wrong slide, but this should be after something else. But let's actually talk about moving the rocket first, all right? So let's, all right, so I only put this so far here, so this is just helping me. So the first thing we do, obviously, right, is we have to create a script. I already created a script called movement, right? And we want to put this inside of the rocket script. But remember, if it's anything of a prefab, always add it inside of that prefab. So what you want to do is go back to the script and instead of adding it inside of the cube, add it on the rocket. Okay, so drag it here, or you can drag on the game object, and you should see that down here. All right, so let's just go back, and you should see that the script should be there. Let's double click that. I think it's already open for me. Oops, it's lagging. So there are actually 2 things we want to make first. We're gonna pass in 2 things. All right, we're gonna pass in the 2 things that we do want to do. Right. So before we start anything, the 2 things we want to do is make a thrust, a method for giving a boost to the rocket, to the character itself, and we also want to make the character rotate. All right. So what we're gonna do first is we're gonna probably make a method on thrust. So we should make a method called process thrust. You could call it whatever you want, but let's call it process thrust. And for rotate, we'll make a method called process rotation. Something like this. All right. But for me, even though it doesn't give any red line or anything, it should be giving a red line. And it's because we haven't made a method for this. Okay, so we need to actually make a method. So for one will be process thrust. And we'll just keep it like that for now. And we'll make another method called process rotation. Something like that. And then what we will do now is we will try doing something inside of each of the process thrust. All right. Remember, we first need to make a rigid body object. So let's make a rigid body object. rigid body. Remember the, not rigid boy, rigid body, and we could just call it RB. Remember that the B is not capitalized. That's one mistake that I did before. And in the start method, we want to make the RB get the component, or in other words, store the component of rigid body. This thing already did it fast for me, so I really appreciate that. If you ever wonder how I did that fast, you could always install tab 9 inside of your extension in Visual Studio. It's going to make things faster. The link is also in the GDC resources. All right, so we have stored RB something, which stores the component of rigid body. So anything that's within here, RB, that object, it stores whatever is within that. So we can access the stuff within rigid body, which is actually super phenomenal, the thing of it. All right, so the idea is we want to do something with the rigid body once we press the space key. And if you recall, we need to use if statements because we want to say if something is pressed, then we do something, right? So let's actually fill that out, something like this. I haven't put anything in, that's why there's a red line. So let's actually fix that. So for us, it's input.getKey. And the GetKey is keycode.space. This is telling me if the space key is if the space key is pressed, then we will do something particular, right? And for us, we want to say RB, which is the object. And once we press dot, we can access the things within that object. So for us, it's going to be AddRelativeForce. We can see that right over here. And inside of that, we're going to try doing something, all right? We're going to try changing it to 0, 1, 0. What I'm trying to say here, if I hover over, I don't know if you could do that, but yeah. Let me try to figure out what I can do by hovering over. Never mind, I don't think it works. But what I'm trying to say is it's going to add a force relative to these coordinates. So x, y, and z are the 3 coordinates that I plugged in, all right, as a parameter. I will change, so wherever I put 0, that basically means I'm not changing that at all. And wherever I put 1, I am going to indeed change that. All right, so let's save that and go back to Unity. All right, so let's go to the rocket. And what I want to do first is decrease the mass to something like 0.2 to avoid any conflictions. Just to check whether I've changed it. Okay, cool. And yeah, let's just give it a try now. And let's just, if I press on it, let's figure out if I press the space key, does it do anything? Let's actually see what I did wrong. Wait, there's something off about this. Hold on. Okay, so I feel like something hasn't been added. Well, maybe I won't be able to show you that. That's actually kind of weird. That shouldn't be a problem. Let me see what I did wrong. Keycode.space GetKey. I guess it's probably a problem by Unity itself. But what we can do alternatively is we could use vector3 itself. So it's going to store all the 3 coordinates where you are currently. And we can do dot up. So they actually have a thing already, a built-in method for this. So it's just going to automatically do the job for us. So in other words, to think of AddRelativeForce, you're adding the force relative to its own direction. Because usually if you just add the force, and you're like, let's say, in any different direction, it's going to always add the force in one single direction. So it's always going to go up. And we don't want to do that because rockets, it should be adding force relative to its direction. So we could add the force based on its angle. All right? Based on where it's located specifically. And that's always good. So I'm just going to change this by 10 or maybe by 100 perhaps. Maybe that would be better. And to keep the frame rate independent, as I always talked about, we should always do time.delta time. And that will just keep the frame rate independent consistently. All right, so I'm still trying to figure out what's up with the code. So this is really odd because Let me try moving the main camera a bit outside so we could see what's going on. I'm gonna probably put that up there, and I'm gonna increase the height. No, I think the X is responsible for this thing. All right, let's just play this. I hope it works. I think it should work. All right, now you can see that. Apparently, I have to put a lot of force into this. Let me do that again. Let me try decreasing the mass even more. I might want to increase that by a really high amount. Okay. So what the idea here is, let me just explain what this is. I don't know why I didn't explain it very well. Basically, the idea is I'm going to multiply this vector3.up, so this relative force, by a constant, which we can actually change using serialized field, which I'll teach you very shortly. And I'm going to multiply all of that by time.delta time to keep the frame rate independent, right? To keep this independent of the frame rate. That's what I'm trying to say. So it shouldn't be dependent on the frame rate. So if you're on any computer, as I talked about this, if you're still confused about time.delta time, you could check on that other video that I've talked about this very deeply. And if you're still confused about it, go check that out. And still, if you're confused about it, just talk in the Unity chat. But what I'm trying to say is this just allows your game to be independent of the frame rate, because this is relying on the update method. So it's going to keep on updating every single frame, and every single computer has different frames. So that's the idea. Let's try to play this game again. Hopefully my constant is very high, so it should make it up. There you go. as you've seen that. So the thing is, if I keep on manually changing the values like this, it's going to be very time consuming. So what we could do is, as I said in those other projects that I've taught you, we can make a serialized field. It didn't do that for me. Serialized field. All right, there you go. And I'm going to have a type float. So it's going to store a float, which is decimals. And I'm going to call this add thrust. I'm going to have this store a constant of 1,000. And eventually, I'm going to do this for rotation as well. And I'm going to probably put that as 1 for now, just for safety. I'm going to save this game. Hopefully this meeting's not getting really boring with the loading and stuff. Let's just play the game again. Okay, I feel okay. Let's probably decrease the thrust by, let's say, 100. I don't know why it wasn't working. Okay. Dude, where did it go? Oh, it's up there. Oh my. Is it back? Okay, we probably might want to play the game again. And the cool part about playtesting is I could just manually change the numbers here, which is good for me. So I'm going to try that now. Yep, that was too high, as I said again. So you can see that up there. It's going up, it's going up, it's going up, it's going up. It's probably going super up, like a rocket. So that's not what we want. Let's play that again. I'm trying to show you like what I'm trying to do. Oh my god, this is... I think I made the mass too small. I think that was my fault there. Yeah, I think that was my fault. I might want to work on that. But usually what people do is they put the drag as 0.25, so it kind of slows them down so that you could keep on pushing in more. I don't know where the rocket went. Oh, there it is. There it is. As you can see here, my game is really lagging. You can see that it fell, but we can see that once I press the spacebar, it's actually going up, and it's going relative to that force that I was talking. So when it went left, it started going to that direction. When it started going up, it started going that direction. That's what I want to talk about, the relative force. It's really, really good tool that you guys should be really aware of, so that you could use that in your future projects. And as I see, we made our own serialized field values here, which is really, really good. So that's good as well. So let's actually save this for now, and let's finalize our thing with rotation, right? So I made a like a helpful description here, like of all the explanation of how things go. So just to recap, I multiplied by add thrust value. Did I even do that? I didn't even do that. I'm so smart. You should change this by add thrust value. Because what happens is you're trying to multiply that by the number that you input here, right? And I think for us that was if I'm not wrong, that was 100, I think. So we multiply that by an add thrust constant, and we multiply that by time not delta time, as I said, frame rate independence. But what it does, it adds the force relative through that direction, and it multiplies by that amount that you put as a constant, so it increases up, it boosts up by that value. Right, and that's the entire idea about this part of the thing. And that only happens if you press the space key. Now let's actually do the rotational things. There are actually going to be two if statements that we need to do. One for the A key and one for the D key. Okay, so let's do input.getKey, keycode.a, and we will do something here, right? But we want to do then we want to do something for the D key. So we do if input dot get key keycode dot d. Oops, sorry, we just did something wrong in coding. We also want to do something here. All right. But here's the thing. We do not want to do in the game where we can press both A and D at the same time. So to prevent that, we could use the else if statement. So what it does, it's only going to perform one or the other. So if this condition has not passed, then it will perform this condition. And if this condition, if this condition has passed, then it will not perform this condition. So vice versa, it's going to only perform either one of the conditions. All right. So what we're going to do first is we're going to transform dot rotate. So obviously anything about rotating objects, it's transformed dot rotating. Now here's where things get a bit confusing for Unity developers, okay? After this thing loads. Loading Unity is amazing, isn't it? All right, we need to open the rocket. Now I need to clear this problem out for everyone, okay? Just because the x-axis here is responsible for left and right movement, that is not necessarily responsible for the horizontal movement for the rotation. Not movement, for the horizontal rotation. So if this is responsible for moving left and right, that does not mean it's responsible for rotating left and right. You can see here, it's responsible for rotating up and down. Similarly, the z-axis is responsible for rotating front and back. But actually, it is responsible for rotating left and right, but in a vertical sense. And y-axis is responsible for up and down, but when you rotate the y value, you're rotating something like this, right? So again, it's rotating horizontal. So it's kind of inverse if you kind of think of it. So what we have to deal with when you're rotating stuff, we have to deal with the z-axis, not the x-axis in the rotation. All right, so keep that in mind. So we're going to go back to our code, and we're going to transform the rotate, and we actually have vector3 dot forward, actually, if you kind of think of it. And actually, if I press enter, apparently it should do the entire work for me. So when I say vector3 dot forward, that is the forward direction of the object. Okay, so it's going to move forward, not going to go up. And it's already a built-in method that people have done for you, that Unity has done for you, so that you don't have to waste so much time. We're going to multiply that by a constant called addRotation, which we've done, right? And we're going to multiply that by time.delta time. So it's going to rotate by a certain amount. All right, we're going to do that the same for... So actually, we could just copy this code to save time. Don't want to type so much today. And we could save that, right? Can we save that, actually? Right. I think we could save that, yeah. So, yeah, we could have either done 0, 0, 1, or we could have done this just like what we've done up here, right? But there is actually one problem. If we move A to the left, and it is actually going to do that, that is true. But it's going to do the same for D as well. But we want to move the opposite direction of D. Well, if you kind of think of it, if we put a negative sign here, it's going to do the opposite of it. It's contralateral. Maybe that's the word. Or it's just opposite of each other. So the moment you add a negative value in front of this vector 3, it's just going to flip the direction of the D for when you press the D key. All right, so this is actually best explained when I do something here, right? So let's actually play. So if I press the spacebar, right? Apparently still it's not doing its job, so let's add the thrust by 100. Maybe that's gonna, or maybe not. That's 1,000, I think. But you can see that it's rotating. We can see that it's rotating, right? But it's not rotating by a large amount. So we should actually change this by 100 probably. But you could see that now it's changing. Let's actually try this again. Let's change the thrust value. I think to, what was it, 1,000? And let's change the rotation value to maybe like 1,000 as well. I don't know. And let's actually figure out, okay, maybe 1,000 is too big. But you can see that it's actually spinning, and it's spinning to, the wrong direction. And that's not what we want. We want to constrain that. So we could actually click on this constraint and constrain the X and Y rotations, because we only want to focus on the Z rotations. And let's actually, play this. So if, okay, we should actually stop the game first and change these things to 1,000, because I don't want to keep on changing it. Alright, so let's just play that again. Maybe 1,000, as I said, for rotation was too high. So let's actually set that to 10, maybe. Maybe not 10, maybe 100. Yeah. So as you can see, you can see that it's rotating, and that's actually what we want. And once I hold the spacebar and I release it, it's going to fall down. And that is what we want for the rocket. So we actually have accomplished our task, except for one thing, okay? This is actually not necessary, but we found this out later that, well, we repeated the code, and that's not what we want as a programmer. We want to try, simplifying the code and maybe not do a lot of repetitions. Once there's a repetition, you should instantly signal in your head that, okay, there could be a simpler way to do this. All right, so maybe what I was planning to do now is you could maybe make another method called do rotation or something, or determine rotation, but we could actually just do rotation as a placeholder name, and I'll just explain what to do. All right, we can multiply by a negative amount if we want or something. All right, so let's actually figure out how to do this. Okay, I think I got it. So what we can do is we could actually just, copy this. Right? And we could actually make a parameter inside. Right? We can make a parameter, and we will basically parameters like passing anything to a method, as we said. And this is a void because this is not going to return anything. It's just a method, right? So let's actually pass in some amount. So it's going to be float, and usually I would just make it the same as what this is over here. Or maybe I would probably want to say a rotation to prevent any confusion. I spelled that wrong. Rotation. Something like that, I think. And what we can do now, a smart approach to this, is we could just call the method for, for each different cases. So here, we could do rotation, and we could pass in a parameter. So for us, since this is opposite, we could just make this add rotation. And over here, we could again do rotation. And instead of, making it negative, we just make it positive. And we just made a simpler way to make the solution. So we just made another method that passes in a number, which is a float. It has a decimal value. It's the same data type as the variable itself. You should always make it the same data type as the variable if you're passing in. And we're gonna pass this. We're gonna call this method in both of the situations to simplify the code. Except in the case for the D key, we're gonna change it to a negative amount. So then when you pass that number inside of this method, it's gonna multiply by a negative amount. So it's gonna go in the opposite direction. So it's just like a more smarter way to fix stuff, and it just simplifies your code even more. So it's a great way to learn how to add logic or some sort of organizational sense in your code. And it's really important as a game developer to do this to avoid any bugs in the future. So in case you come back to the game after like a few years and you don't know what's going on, having a simplified code just always simplifies what you've learned, and it saves more time in understanding what you need to know when you debug your game. All right, so let's just check on the rocket in case I fixed anything. So let's just change this by 100, I think. And I think I did something, didn't I? Oh, okay. All right, I forgot to put the T here. Sorry about that. All right, I think the problem's cleared out. But let's play the game. Let's see if the thing has worked or not. Debugging is always good. And as you see, it's actually working. So today, we've actually figured out how to move our character and how to do all the necessary things to make your game, all the game fundamentals. And we also made the simple things for the game, how to start off making the character itself, and how to build up later on, how to create basically a good foundation for developing a game so that you could progress better in the future, in the future, basically. All right, so that's basically it for this meeting. So let me just debrief you guys on what we've learned today. So in today's meeting, we've learned a few things. We learned essentially about like how to process the thrust, how to do these input get key stuff, basically getting in touch with these things. We also like learned on how to start a good foundation, as we said. We also made our own character movement, a cool way to do that. Basically, we learned a lot of things today. It was quite a long class. It ended at 4 o'clock. Sorry about that. Uh, since I have wait, yes, okay, my bad. So yeah, this is basically it for today's meeting. I hope you learned something from this meeting, especially, and I hope to see you in the next week of GDC class number 13. So if you have any questions, share it in the Unity channel. I'll be sure to add any homework assignments if there are any. Maybe there won't be this week, so be happy for that. So yeah, thanks guys. Peace.